Welcome to this video. In this video, we'll be dealing with the concept of continuity, and it is absolutely critical that we understand continuity from its definition. So let's read out. A function f of x is said to be continuous at x equals to c if and only if we take the limit of f of x at c from the left, that must equal to the limit of f of x going to c from the right, and that must equal to the function where c you're substituting it wherever you find x. So that is the condition that you need for continuity. So let us dive deep into the first question to see how we'll be able to sort that out. So let's start with the first one. Is f of x, so f of x is this piecewise function, as you can see it over here. Is f of x continuous at x equals to 1? So let's check that out. So what we are firstly going to do is to firstly check out the limit of f of x as x tends to 1 from the left. So as x tends to 1 from the left, it will inevitably bump into this function. So the function that we will meet is this one over here. So now we will take the limit when x tends to 1 from the left. So wherever we find x, we'll substitute 1 and see where that leads us. So 1 squared plus 3 just gives us what 4 is. The second thing we will do, we'll now take the limit of f of x as x tends to 1 from the right. But now when we are going to 1 from the right, we will inevitably bump into this function. So the function we bump to from the right is that one over there. So we'll now take the limit of that. So wherever we find x, we will substitute 1 there. So therefore, we also get 4. So we can see that the limit from the left equals to the limit from the right. So the last thing we will then check is if the function at x is equals to that. So we'll come and substitute f of 1, and we can clearly see when x equals to 1, its corresponding y value will be 4. So therefore we get 4 there. So we can clearly see that the limit from the left and the limit from the right as you tend towards 1 gives you 4, and also the function when you get to 1 does give you 4. So we say that f is continuous. Let's check the spelling. It's continuous at x equals 1. So remember, this condition had to be true. Let's do one more example. So let us look at the next example to see if we're able to do that. The first thing we'll do, we'll take the limit as x tends to 2 from the left. So as x tends to 2 from the left, it will inevitably bump into that function first. So 3x minus 1. We then want to check this limit. So wherever we find x, we'll substitute 2. So that then gives us 5. So that is perfect. So the limit there is the same. Let's see if we're able to do the next one. So we'll then again take the limit as x tends to 2 from the right. So inevitably, when we turn into 2 from the right, we will bump into that particular function. So therefore, we then substitute 2 wherever we find x, and therefore we can see that that is 5. So the limit from the left and the limit from the right exist. Well, they give you both 5. The next thing we then want to check, we want to check what g of 2 is. But we can clearly see here, where in our statement, we don't have a situation like we did in our first one. What happens when x is equals to 2? All of these situations, x is therefore not equals to 2. So we say that g is equals to 2 is not defined. So it does not exist or is not well defined. Not well defined. So because of that, we cannot then agree to all these 3 conditions. We do not satisfy the 3 conditions. So therefore, we don't have enough information to say that g is continuous at x. So we say that g is not continuous at x is equals to 2. All right. I hope this has made some sense. We'll do some more miscellaneous types of questions.